Hi everyone, this is Michał from Airhead, and today we'll go through some of the most recent questions from the topic of GINA. These were all seen in the last 30 days in the actual EASA exams across all authorities. So without any further ado, let's just jump into the questions and go through the possible answers and explanations. So given the following information, we need to convert the ground distance to air distance. For these types of questions, the only thing you need to know is one simple formula, which is the true airspeed divided by ground speed equals to nautical air miles divided by nautical ground miles. And if you use this formula, you'll be able to solve all of these questions. And also remember that if you have headwind, as it is in this case, you can see the ground speed is lower than the true airspeed. If we have headwind, it means that our uh, nautical air miles will always be more than our ground miles. So this will help you narrow down the possible answers. However, in this case, following the equation, we have the true airspeed and ground speed. And here we can see that we were given the IS just to trick us, as we will not need this information at all to solve this problem. So we have the true airspeed divided by ground speed, which is 1.1. And then we have our nautical ground distance, which is 120. And this gives us 132 nautical air miles. And as you can see, this is more than our ground miles because we are flying with headwind. So we need to cover more distance through the air. So now going into question number 2. Calculate the ground speed of the aircraft on a flight between the two observed fixes stated below. So we have Regensburg, which are passing at 10:22, and we have Arnbrook, which we are passing at 10:38. So immediately we can see that the time between these two stations is 16 minutes. So this is an important information. And now what else can we see? We see that the stations are positioned directly above each other. So they are above each other. You can see that they are both on the same latitude of 49 degrees and 8 minutes. And this means that all we need to do is we need to calculate the distance covered. However, this can be slightly tricky because when it comes to the longitudes, we cannot just take the minutes and degrees as it is with latitudes. We need to calculate something that is called departure. And the departure is always the change of longitude in minutes times the cosine of latitude. And this will give us our distance in nautical miles. And of course, this is the biggest trick in this question. And you can calculate the minutes and convert them to nautical miles immediately only when we're talking about latitudes or if you are at the equator. So doing exactly that, calculating departure, we have the difference in minutes, which will be 54 times the cosine of our latitude, which is 4908. I think if we just use 49, this will give us a close and good enough answer. And so calculating all this in your calculators, so 53 times the cosine of 49, this gives us 35.4 nautical miles. So all we need to do now is to calculate the speed needed to cover 35.4 nautical miles in 16 minutes. There are two ways of doing it. You can use the formula, but if you do, remember to use the SI units. So either you need to use the hours and nautical miles or seconds. However, the easiest way to do that is to just calculate speed factor, meaning that if we're covering 35 miles, 35.4 miles in 60 minutes, this means that in 1 minute we'll cover 2.2 miles, and that means that per hour in 60 minutes we'll cover 132.75 miles in knots. This is the closest answer, really. And just to let you know, if you forget to calculate departure and you just take the straight minutes and degrees, the correct answer would be 202, the incorrect answer, but the one you get is 202 knots. So this is the trick and something to be careful of in this question. And now going to the next one, the pilot of an aircraft during descent with constant CAS of 120 knots observes a true airspeed of 135 knots at flight level 80. What will be the true airspeed if she checks again the instruments later? So this question is asking us about the very popular and the very well-known mnemonic, which is the chicken tikka masala. So what happens to different airspeeds as you climb or descend? So of course we know that if we're climbing with constant CAS, which is the C from the mnemonic, both the true airspeed and Mach number will decrease in descent and they will increase in a climb. So if our CAS is 120 and we're descending, that means that throughout the descent, the CAS will be decreasing. So it has to be lower than 135. And we have two answers that are lower than 135, 119 and 131. However, here all you need to remember is that your CAS can never be lower than your CAS. They will be very, very close to each other at the surface. However, the CAS will never really be below your calibrated airspeed, which is the dynamic pressure. So in this case, the 119 is an impossible answer, and the only one that makes sense is 131 knots. And also for questions like these, you can remember that for every 1,000 feet, the difference between CAS and TAS will be around 2%. So if you're climbing with constant CAS 100 and you're passing 1,000 feet, that means your CAS will be around 102. And as you go higher, it's 2% or 1,000 is a good rule of thumb that you can use. So the next question is, we are going, there is a VOR and we're flying with a true course of 90 degrees starting at a certain latitude and longitude. So when we are at radial 360, what is the range from the VOR to the aircraft? So this question is actually extremely easy once you imagine everything and draw it out. Because what's happening here? Our aircraft is flying to the right side, so it's keeping its latitude. So the 51 degrees and 07 minutes north will not change at all for the VOR, of course, but for our aircraft as well. So 53.04 north is not changing as we're following a true course of 90 degrees. And what happens when we are on radial 360? The radial 360 radiates directly to the north from the VOR. And in this particular case, when the variation is 0, that means when we are on the radial, we are directly above the VOR. So all we need to calculate is the difference of latitudes. And on latitudes, it's always 1 minute equals to 1 nautical mile. So in this case, we are above the VOR. We are 2 degrees without 3 minutes. So this will be 117 minutes. Remember, 1 degree is 60 minutes. So 170 nautical miles, we will be above the VOR as we pass directly above it on this latitude for the VOR and this latitude for the aircraft, which remain unchanged because we are flying at the true course of 0980. And now for the last question, an aircraft flying at 3,000 feet commences a climb at a point A on a 3-degree glide path with an average ground speed of 210 knots. The aircraft will reach the altitude of 8,000 feet at a certain time and will cover a certain distance. So here we have to, the trick that you have to watch out for is that, of course, we are going to climb 5,000 feet. So the vertical distance we need to cover is 5,000 feet on a path of 3 degrees. Rule of thumb for these, the 3-degree glide slope or climbing is that your ground speed times 5 is your vertical speed. So in this case, your vertical speed for the 3-degree glide path will be 1,050 feet. That means that 5,000 feet will be covered in 4 minutes and around 45 seconds. And there is only one answer that gives us exactly that. If you want to calculate the distance, all you need to do is just to get a speed factor, which is 210 divided by 60. And then this times the 4 minutes will give us the correct answer. However, this is everything for today. Remember, 5 times ground speed for 3 degrees will give you a rate of climb or descent, and this is all you need to know for these questions. Hope this was helpful, and I wish you all the best in your exams. Bye-bye.